Alright guys, so today we're going to be finishing up section 4.6. For this part, what we're going to be looking at is we would like to have some idea of how many solutions we should expect to have. So when we have a polynomial, we can have like 5 positive solutions, or we might have 3 negative solutions. So Descarte was a mathematician back in the 1500s, and he came up with this rule of signs that can help us to know that. Let's go down here first though. These are types of answers that we can get when we solve polynomials. What kind of solution is this? Is it a positive real, a negative real, or imaginary? Imaginary, so this would be imaginary. What's this one? Negative real. What's this one? Positive real. It is irrational, but irrational numbers are real numbers. These are the only choices we have to choose from. What about I? Imaginary. And negative 2 plus radical 10, what would that be? Positive real. How did you know it was a positive real and not a negative real? Yeah, square root of 10 is over 3, so if we have negative 2 plus something around 3, that's going to be positive real. So, Descartes' rule of sign says this: the number of positive real zeros of a function is going to be equal to the number of changes in sign of the coefficients of f of x, or it is less than this by an even number. I just want to show you a quick example. Let's say we have this: x to the 4th plus x cubed minus x squared plus x minus 4. This is our function. How many changes in sign do we have? Well, it goes positive to positive. Is that a change? No. Positive to negative. Is that a change? So we have 1. Is this one a change? So we have 2. Is that one a change? Yes, so we have 3. So what that tells us then is we can have 3 positive real solutions, 3 positive real zeros, okay? But it says it can also be less than this by an even number. So I could have 3 positive reals, or what else could we have? 1. That's the only possibility. We either have 3 positive reals or we have 1 positive real. Could we have 0 positive reals? No. Only 3 or 1. Okay? The next one. The number of negative real zeros of a function is equal to the number of changes in sign of the coefficients of f of negative x, or is less than this by an even number. F of negative x means in this function, I have to replace every x with a negative x. So here's an x. Replace it with a negative x. Here's an x. Negative x. Here's an x. Negative x. And now I have to simplify that. If I have a negative to the 4th, is it positive or negative? Positive. If I have a negative cubed, is it positive or negative? Negative. If I have a negative squared, that's positive times negative is negative. Then I have a positive times a negative, that's negative. And then I have a negative 4. How many changes in the sign did I have? I had just 1 change. So that tells me then I could only have 1 real negative 0. Back here, I could have 3 or 1 real positive 0. Okay? So what that means is I could have 3 positive reals and 1 negative real. How many solutions total would I have to have? 4. What if I had 3 positive reals and 1 negative real, and I have to have 4 total solutions? What do you think the other 2 must be? I have to have 4 solutions. So if I had 1 positive real, 1 negative real, What must the other two be? Imaginary, right. Okay? So that's the only possibility. I could have 3 positive real, 1 negative real, and 0 imaginaries. Or I could have 1 positive real, 1 negative real, and I would have to then have 2 imaginaries. And that's because I have to have 4 solutions. Okay? Alright, let's come down here. Examples. Determine the possible number of positive real zeros, negative real zeros, and imaginary zeros. That's all we're doing on the first 2. Looking at the sign changes. How many changes in sign do we have at the beginning? 1. So that means I can have 1 positive real. Now we're going to plug in a negative for x. If I do negative x cubed, that's negative, times a negative would be a positive. Negative x squared would be positive times a positive. And then that's automatically positive. How many sign changes did I have? 0. So I'm going to have 0 negative reals. Now, we're going to put this in chart form. So, positive reals, negative reals, and imaginary. Well, all I can have is 1 positive real, 0 negative reals, but I have to have 3 solutions. 2 imaginary. Good. Okay, does that make sense? Now, if I thought about this, I could have zeros of plus or minus 1, 2, 3, 4, 6, and 12. Would it make sense for me to use synthetic division and check negative 1, negative 2, negative 3, negative 4? No, I already know I don't have any negative real solutions. So it would be a waste of time to check those. I would only want to check positive 1, positive 2, positive 3, positive 4. You see what I mean? That's what we are using this for, to narrow down our choices. Alright, looking at this one, how many sign changes do we have at the beginning? How many? 3? Everybody see the 3? Positive to positive, no. Positive to negative, yes. Negative to negative, no. Negative to positive, yes. Positive to negative, yes. 3 sign changes. The coefficients change signs 3 times. There, and there. So that means I can have, for my positive reals, how many can I have? 3 or what else? 1. I can either have 3 or 1. That's because those imaginaries have to come in pairs. That's why this can be 3 or it could be 1. Because the other 2 have to come in pairs. Remember how if 2 plus I is a solution, so is 2 minus I? They have to come in pairs. That's the reason why for this. Negative reals. I'm going to have to plug in a negative. Negative x to the 5th would be negative x to the 5th. Negative to the 4th is positive times a positive. Negative is cubed is negative times a negative. Negative squared is positive times a negative. Negative times positive is negative, and that's negative. So that's what I get when I put in a negative. That's my g of negative x. How many sign changes? Okay, so for my negative reals, I can have 2, or how many else could I have? 0. I cannot have 1. It's impossible for me to have 1. I can have 2, or I can have less than this by an even number. What if this had been 5 negative reals? How many could I have? I could have 5, I could have what? 3, or I could have 1, right. Now we're going to write down all the options in our chart. So I'm going to just put PR for positive reals, NR, negative reals, or imaginary. So I have to do all combinations possible. I can have 3 positive reals. How many negatives? 2. I cannot have 1. How many total solutions do I have to have? Okay, so how many imaginary would I have in this case? 0. Okay. Now I could have 3 positive reals and how many negative reals? 0. Then how many imaginary would I have? 2. So we might know what the next option would be. 1 what? 2 and 2. Okay, and then what would be the only other way it could work? You got it. Those are the only options. So if I gave you this function and I said, is it possible to have 1 negative real 0, what would you say? No. You can't have just 1. And I would have to say just 1. Because you could say, well, you could have 2, so you could have 1 plus another 1. See what I mean? Alright, how are we going to use that now? We're going to do just this problem. This one is difficult. This one's a little easier, and I want to do the harder one. So how this would actually work. How many sign changes do we have at the beginning? 1. So I know then, for my positive reals, I can only have 1 positive real. Okay, now I'm going to plug in a negative. That would make this negative x to the 5th. This would be negative x to the 3rd. That would still be negative 2x squared. That would be negative times negative positive, and that would stay negative. That's what I get when I do h of negative x. You can do that slower if you need to. This is negative. Kind of got offline. Alright, how many sign changes do I have then when I plug in the negative for x? 2. So I can have 2 or what else? 0. Okay, so for my negative reals, I could have 2. How many imaginaries would I have to have? Okay. What else could I have? What are some other options? 1, 0, and 4. Okay. Anything else that's possible? No, can't go up. Alright, so I'm now going to look at my possible zeros. My rational root theorem. I can have plus or minus the factors of this divided by the factors of 1. Well, that's just going to be the factors of this. So I can have plus or minus 1, 2, 4, or 8.
Pardon the interruption. Teachers, just to let you know that the SOB members are returning back from Lakota East at this time. Please accept them into your room without a pass. Thank you.
What do you guys think makes the most sense to check?
1.
Positive 1? I agree. Instead of checking negative 1, I would rather check positive 1. Why? Because I might have what? I might not have any negative real solutions, right? So why not find that 1 positive first? So I'm going to check 1 with synthetic division. I'm going to bring this down. That's 1. That's 1, 1. That's 1. That's 2. 2, 0. 0, negative 12. That's not going to work, is it? Okay, so 1 didn't work. What might I want to check now? 2. Just doing synthetic division. I bring this down. Multiply and add. Multiply and add. Oh, that's going to work. Good. Okay, so there we go. That worked. So now I have one of my zeros. X equals 2 is one of my zeros. How many zeros do I have to find? 5. Okay? Now, am I going to check 4 and 8? No. Because I'm only allowed to have one positive real zero. I'm wasting time if I do that. They're not going to work. Could -1, -2, -4, could they work? Yeah, so I might want to go ahead and check them. Let's check -1. You can just watch. You don't even have to write this down unless you want to. Oh, good. That worked. Okay, so -1 worked. So now I'm up to 2 zeros, getting closer. Now, here's the thing, guys. I don't have to keep using this. In fact, actually, I wish I would have just used this on the -1. That would have been a lot better. Okay, that's all right, though. We can correct that. I'm going to redo -1. I know it works, but I'm going to just use it on this instead because I want to get my powers lower. See, this is now x to the 4th, x to the 3rd, x to the 2nd, x, and a constant. But I still wouldn't be able to factor that, so I know -1 works, and it should work in here as well. It has to. I know this is something we have not done, but we're taking what's left here, and we already know -1 should work. So it's -1, that's 1, -4, that's 4, that's -4. There we go. The reason I did that is because I want to get this down to something I can factor. This is my constant, this is my x, this is my x squared, this is my x cubed. So now I've got x cubed plus x squared plus 4x plus 4 must equal 0. Can we factor that? Sure. What do I factor out of these two? Okay, I'm going to come up here where I have some room. So I'm going to factor out x squared, and I've got x plus 1. What can we factor out of these two? So I take out a 4, and I'm left with x plus 1. What can I now factor out of each of those? X plus 1, and I'm left with x squared plus 4. So now I can set this equal to 0. So what's another one of my zeros? -1. So that is called a multiplicity of 2. That means it would bounce right there because I have a multiplicity of 2 right there. Okay? This is my other one that's going to give me my solutions. Do you guys know what solutions that's going to give me? Good. X squared equals -4. So take the square root plus or minus, what is the square root of -4? 2i. So another solution is 2i, and the last one is -2i. And does that make sense? Well, we had one positive, we have 2 negatives, and we have 2 imaginaries. Okay? Sure. All this means is that it was a multiplicity of 2. Yep.
So was the only way to find out if there's 2 of the same numbers to factor it like a different way?
Right. And that's why I went back and I said, ooh, I wish I would have done the -1 in here so I could factor, because I probably wouldn't think to check -1 again, and then I would have gone through and checked -2, -4, -8. None of them would have worked, and then I would have known it had to be -1. So it's always better to use this smaller portion of it. Okay? That's always going to work. All right, guys, we're going to just do one more. We're going to do this one. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So one of our zeros is 8. What was the factor if 8 is our 0? Good. If 3 minus I is a 0, what else is a 0? Can you tell me the sum of those? These two? Good. The product I'd have to FOIL. 3 times 3 is 9. Outers is positive 3i. Inners is negative 3i. Those are 0. And then minus I squared. It's not 1 though. It's minus, what's I squared again? -1. So what would it really be then? 10. So now I know I've got x minus 8. These two, the factor would be x squared minus the sum x plus the product. And then to get my final answer, I would just have to multiply this all out. So I'd have x cubed minus 6x squared plus 10x. I'd have negative 8x squared plus 48x minus 80. I'm going to see what they want me to name this, f. Okay, so f is going to equal x cubed minus 14x squared plus 58x minus 80. Looking at the sign changes, 1, 2, 3. I could have 3 positive reals. I don't have 3 positive reals though, I only have 1. Is that okay? Yeah. And I had 2 imaginaries. Okay? So guys, now is the time where all of this should start kind of making sense and you should see how it's all kind of connected to each other. And we're going to still be working on this for like another week and a half, but this is the major concept.